Hello my dear students, today we are going to continue the atom by just understanding, explaining the structures, the particles inside the atom. So, if you have any questions from yesterday, you can revise what we learned from the book, or you can just revise the subjects from the PDF files that you have. So, remember where we left yesterday? We were talking about the particles inside the atom. So normally we are using this atomic model as a representation of an atom, any ordinary atom. We are saying that in the middle or in the center we have something called as nucleus, and around this nucleus we have we have electron particles. And we are saying that protons are positively charged particles. On the other hand, neutrons are neutral particles which are not charged at all. And electrons are negatively charged particles. So, nucleus is the very dense, very small center of atom. Okay? It only contains these two particles. And the proton has only positive charge, and it is only found in the nucleus. The atomic number of an atom is basically the number of protons inside the nucleus. The number of protons inside the nucleus is defining the type of the atom. If we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Protons here, the atomic number of this atom is 9, basically. And the neutrons are neutral charged or zero charged particles inside the nucleus. And the number of neutrons and protons will give us the mass number of atom. So imagine that even though they are really simple, they still have a mass, right? Because they are basically particles. So the mass number of an atom will be given by the number of neutrons and number of protons. So what about electrons then? They have negative charge, and they are found in the electron cloud. And in an atom, the number of electrons equals to the number of protons. So overall, we are expecting the atom has zero charge because they will equalize to each other. Okay? In a pure element, in a pure atom, we are expecting the electron number should be equal to the proton number. We can know the place of protons and neutrons. They are found in nucleus, but we cannot know the place of an electron. They are always moving. They are always in the move. So what is atomic number and what is mass number that we try to understand in the previous slide? So an atomic number is the number of protons inside the nucleus. We have, for example, a carbon and oxygen atom. Okay, they are different elements. That's why they have different numbers of protons and neutrons here. So the number of protons an atom has is important because it determines the element. For example, we have 1, 2, 3, 4, 5, 6 protons here. So 6 protons can only be found inside the carbon atom, okay, inside the carbon element. On the other hand, we have 1, 2, 3, 4, 5, 6, 7, 8. And like this, 8 protons can only be found in oxygen atom or oxygen elements. Okay, that's why the number of protons are giving the identity of this atom, and they are also giving us the atomic number. Okay, so this atomic number are telling us is telling us two things: how many protons the atom has, right? The atomic number. From atomic number we can understand the protons inside the nucleus, and also what type of element is this. Okay, this atomic number also, because it is special to element with different elements, we can understand what type of element is this by just looking at the atomic number. On the other hand, what about mass number? So we say that it should have a mass, even though this mass will be really small because it's a really small particle we are talking about here, but still it has a mass. So the mass number is the number of protons and neutrons inside the nucleus. Okay? For example, we have 6 protons and 6 neutrons inside the nucleus of a carbon atom. So the mass number will be calculated by just adding these numbers together. So let's try to solve this question together in order to make it more clear. We need to place these parts of the atom to these labels. So let's start with neutron. What we say that neutrons are found in the nucleus and they are neutral, they don't have any charge. That's why we should place them on these white particles, because they are the only ones who doesn't have the any charge. Okay, and on the other hand, when we are talking about nucleus, we know that it is at the center and it is containing the positive and positively charged protons and neutrons. So protons, that we said that they are positively charged, that's why we are placing protons here. And what we said that electron cloud is the space around the nucleus. Okay, so that's why we are placing electron cloud here, and the electrons are negatively charged particles around the atom. So when this is just a model of an atom, and the atomic theory tells us that even though they are really small, these particles are really small, they are the essence of the atom, and they have really big spaces. We have really big space inside the atom. Okay, so almost all of these circular shape, almost all of these space is empty actually, because nucleus is really small and dense structure. But even though we say that this an atom can have a lot of space around its nucleus, the space are always filled with electrons which are moving around the nucleus. They are really fast, they are always in motion, and we can't know the exact places of nucleus. The electrons. So, and they are the basic reason, this movement is the basic reason of electrical connection. So the last thing that I want to mention about this atomic number and the properties of atoms is isotopes. So let's check these two different nucleuses. It is asking us, does all the atoms that contain these nucleus have the same atomic number? So we have 1, 2, 3, 4, 5, 6 protons and 2, 4, 6, 8, 9 neutrons here. On the other hand, we have 6 protons and 6 neutrons here. So we say that atomic number is equals to the proton number. But we also say that almost always neutrons are equal to the number of protons. So the problem is in here, in this one, we have more neutrons than protons. So basically we should say yes, the atomic number should be the same, but because each nucleus has 6 protons. Both are carbon atoms, both are the same atoms, but their mass number is different. So we call these type of atoms as isotopes. So isotopes are the atoms of the same element that have different numbers of neutrons. Okay? Sometimes we can see isotopes in our topics, the topics that we are going to discuss. So just remember, just keep in mind that we may have isotopes of the same element, but most of the time the atoms of an element will have the same number of protons and neutrons. Okay, so that's enough for today. See you in the next session. We will continue with the periodic table, and if you want to revise what we learned today, please open page 162 and 166, and that's enough. Thank you for listening. See you in the next session.